Hello, my name is Darwin. I wanted to talk to you today about a solution that I've come up with for a device cloud for embedded development. This can help you critically widen some of your hardware in the loop testing bottlenecks, as well as do global device sharing. Now, as we go through, you should be aware that this is a solution. So, like you see in a lot of the cloud providers, if you ask them for a solution for something, they will use some code to put together parts of their system to work for you. And that's exactly what this is inside of GitLab. Also, GitLab has a new capability for creating, sharing, and standardizing solutions known as GitLab CI CD components. So, this solution also leverages CI CD components in order to make it much more usable and production grade. So, let's dive right in. Before we dig into the how, I want to dig a little bit into the why of why we want to get hardware and get it into CI so that we can use it there. So fundamentally, embedded systems have been dealing with specific kinds of problems around bottlenecking because of the use and the need for the use of real hardware at some point in the process. Doing manual builds right on the hardware, definitely doing testing on the actual hardware, and then the deployment phase is another aspect of getting this out the door. So we can see this bottleneck creates around the hardware where we have these two triangles indicating that we get bottlenecked there in the middle. One of the biggest problems of this is a very slow feedback cycle. So we don't know if something's working or working correctly because the feedback cycles are a lot longer. Of course, if we have hardware at the desk, that's one thing, but anyone who's developing on hardware compilations that are very complicated or expensive, generally we're dealing with expensive shared hardware there. And so what we need is something that allows us to share that hardware, especially if it's of the expensive type. AI is on everyone's minds. It generates a lot of innovation and faster innovation at the coding end of the funnel. So having the hardware in the loop allows us to potentially open up these bottlenecks a little bit. So with AI accelerated coding, we want to make sure that we open up that bottleneck. You need to do it anyway, even if AI is not on your immediate radar for any reason. You can get innovations to customers much faster when you have this bottleneck removed. One of the ways we can do that is to start to get build into cloud CPUs as quickly as possible. So in any case where you can actually do a legitimate bit for bit compile on a cloud CPU like an ARM CPU, that's a great way to get started. That is truly unlimited. You can scale as large as you need it or as you want to facilitate the velocity of development. Another aspect is getting some test coverage with emulation. Here, I'm just saying 60%. In a lot of cases, it's a lot better than that. But anytime we can use emulated systems to get some early feedback, it's better. And then testing on representative hardware. Sometimes just having hardware that's very similar to, but not identical, is a lot cheaper than having the full-on production rig that we need to use. The solution that we're going to talk about is trying to innovate. So having that device cloud of your own devices. And then next, we have full-on testing. We could create both of these as different pools. We could create as many pools as we want to if necessary. So the whole concept here is getting that hardware feedback loop to speed up. But that's not the only benefit. When we do this sort of incremental build where we move CI first, and then we have partial test coverage, more partial test coverage, and full test coverage, we also shorten the loop at each of these points where we have a system that's getting closer and closer to the full production rig. And the reason that's important is if you think about it in a practical sense, do you really want to figure out that your code has a math error by running it on the full production rig after waiting for some period of time, getting all set up and deploying it? It'd be much better to learn that much earlier in the process, like in a cloud CPU. So this is the concept behind getting this fundamental speed up in embedded development. And so now we'll talk a little bit about the actual device cloud component.